Good morning, everybody, dear students. We have covered, we have completed up to chapter number 2, that is first two chapters in statistics. Today we are going to start chapter number 3, that is linear regression analysis. Now the question is, what is regression? Two chapters, chapter number 2 and chapter number 3. Both are connected chapter, correlated chapter. Second chapter namely linear correlation and the third one is linear regression. What is correlation and what is regression? Correlation means association between two or more variables and regression means estimation of unknown variable with the help of known variable. One is dependent variable, another is independent variable. Generally there are two variables. Generally there are two number of the variables, x and y, variable x and variable y. If x is given and if you want to estimate y, then this is regression line of y on x. Regression line of y on x. There are generally two regression equations. Regression line of y on x and regression line of x on y. Y cap is given by a plus bx and x cap is given by c plus by. These are the equations of regression lines. Simple equation, linear equations. To estimate y, it is given by y cap a plus bx. This b is nothing but byx, which is the regression coefficient of y on x. Here y depends on x. X as varies. Value of x means changes. Then y also going to change. And in another form, x cap equal to c plus by. Here x is depends on y. X depends on y means x on y. Regression line of x on y is given by x cap equal to c plus by. This is nothing but bxy. And bxy is regression coefficient of x on y. This b and this b little different because this b is regression coefficient of y on x. This b means regression coefficient of x on y. Generally there are two variables x and y and hence there are two regression lines y on x and x on y. Y on x means y depends upon x. If value of x is given, we can estimate y. If value of y is given, we can estimate the value of x. These are the standard form. How to obtain the small a and small c? Small a is given by y bar for this value. Small a is given by y bar minus b times x bar. And small c is given by x bar minus b times y bar. Small a and small c can be calculated as a is given by y bar minus b times x bar and c is given by x bar minus b times y bar. How to compute byx and bxy, the regression coefficients? Generally you have to write on the page opposite side, means this page, on this page left hand side byx and on the right hand side page bxy. This is the all fundamental things, all basic material of this chapter. Byx means b, which is nothing but regression coefficient of y on x, and bxy equal to b, regression coefficient of x on y. Now different formula for calculating byx. Byx is given by one of the formulas r into sy upon sx. Yx sy upon sx. Sy means standard deviation of y, sx means standard deviation of the series x. Another formula for byx, covariance between x and y upon sx square. Covariance means sxy, sx square means variance of the series x. Variance or variance of the series x. This is also one of the formula. If x bar and y bar both are completely integer values, then Byx is given by sigma x minus x bar into y minus y bar upon sigma x minus x bar whole square. Sigma x minus x bar whole square in the denominator. There is no square root. See the difference of the formula for correlation and for regression. Here in the denominator, sigma x minus x bar whole square. These are the formula for computing Vyx. These are the formula for computing Vyx. The regression coefficient of y on x. Y on x. If the values of x and y are very small in values, generally it is given by tan times sigma xy minus sigma x into sigma y upon means divided by tan times sigma x square minus sigma x complete square. Or UV form, if we divide series x by cx and series y by cy, common factor of the series x and common factor of the series y, then it is given by n times sigma uv minus sigma u into sigma v divided by n times sigma u square minus sigma u whole square multiply by this yx, therefore cy upon cx. Cy means common factor of the series y upon common factor of the series x, where u is given by x minus a upon cx, v is given by y minus b upon c. Similarly, you can easily prepare pxy. Pxy means regression coefficient of x onward. There are two regression lines. Generally in our syllabus, we make use of y on x. Generally in our syllabus, we make use of this formula only. But for your kind knowledge, for your kind consideration, we also give this formula for bxy. Bxy is given by here sy upon sx. Similarly, bxy is given by r into sx upon sy. Standard deviation of the series x upon standard deviation of the series y. It is also given by covariance between x and y upon sy square, the variance of the series y. It is also given by for x bar and y bar both are completely integer values. Sigma x minus x bar into y minus y bar upon sigma y minus y bar complete square, whole square. If x and y are so small in values, then it is given by n times sigma xy minus sigma x into sigma y upon n times sigma y square minus sigma y whole square. For u and v conversion, for u and v transformation, it is also given by n times sigma uv minus sigma u into sigma v upon n times sigma v square minus sigma v whole square multiply by cx upon cy, the common factor of this is x and common factor of this is y, where u is given by x minus a upon cx and v is given by y minus b upon c bar. See, these are the fundamental and basic material, the foundation of this chapter. You must prepare, you must remember, you have to write this formula for 5 times. These are the structure, this is a structure of this chapter, linear regression analysis. And in the complete chapter, whatever may be method of numericals, numerical example, practical example, this formula must be used in different kind and different examples. So Vyx r into yx sy upon sx, here x is the last word, covariance between x and y, sx square, x is the last letter, sigma x minus x bar into y minus y bar, sigma x minus x bar whole square, x is the last letter, n times sigma xy minus sigma x into sigma y upon n times x is the last letter, sigma x square minus sigma x whole square. Here yx, this is v and this is u, therefore n times sigma uv minus sigma u sigma v upon n times sigma u square minus sigma u whole square. Now, what are the properties of? You can easily prepare the formula for this. Here sy upon sx, here sx upon sy. Here sx square in the denominator, this is sy square in the denominator. Therefore, numerator remains same. See, in each of the formula, here covariance xy, covariance xy. then sigma x minus x bar into y minus y bar. In almost all formula, numerator remains same, unchanged. Now properties of regression coefficients. There are two regression coefficients, namely dyx and dxy. dxy means regression coefficient of x on y, and dyx regression coefficient of y on x. What are the properties of regression coefficients? Then number one, the correlation coefficient, that is R, and both the regression coefficient dyx and dxy must have same sign. Therefore, signature of sign of R, dyx and dxy are equal sign, same sign. Further, regression coefficients are independent of change of origin but not of the scale. If you add, if you subtract some value to the series x and y, then there is no change. But if you multiply and divide to the series x and y, then dyx and dxy are going to be changed. And therefore it is said that regression coefficients are independent of change of origin but not of the scale. And finally, further, R is given by plus or minus root of dyx into dxy. This is also one of the property of regression coefficient as well as coefficient of correlation. And finally, the coefficient of determination. Here, determination sign is capital R square. Sign of determination is capital R square. And R square is given by Rxy whole square. Means capital R square equal to small r square. And always R square is positive. And the range of R square, we know that value of R, coefficient of correlation lies between -1 and +1. But coefficient of determination lies between 0 and 1, inclusive of both the values. And that is why 0 less than or equal to R square, less than or equal to 1. See, one important thing. We have covered first two lessons, first two chapters in statistics, index numbers and linear correlation. You must practice according to our video lectures and according to our PDF and according to our textbook. So prepare and complete your notes. Prepare and complete your notes according to video lectures, according to PDF file, whatever may be sent to you, and from our textbook also, illustration examples as well as examples from exercise. Anytime your notebook can be checked by class teacher or by subject teacher or by Hardik sir or Kalarav madam, and so please practice at home. This is a very important thing for you. Basic material, foundation, fundamental of the chapter 3. You must prepare this and please write, please prepare for 3 to 5 times this. And whole chapter, in whole chapter, these are the very useful things. And so, please be prepared well and study at home. Stay at home and study at home. And be careful for your health and for your family members also. Nice to meet you. Thank you everybody. Thank you so much.